need to use. Thank you. Okay, so I'd like to introduce to you now Enda McDonagh from Enda. You're the environmental manager at Enda and going to chat to us a little bit about the journey to 50,001. And I think I'd certainly say to you, just in terms of what I mentioned earlier and transport, etc., I think one of the little known facts about Enda is I think you have one of the largest railway networks in Europe. Yeah, yep. And that's it. And one of the largest tractor fleets.
Yes.
Yeah, as well as everything else you do.
Very proud of
that. Yeah. Over to you, Enda.
Okay.
Cheers.
Good morning, everyone. Connie might give me a shout on time. I have a lot of slides here, so I do tend to ramble them a bit. Okay, what we do, we supply peat for power generation. A brief history of Enda first, Enda today, and then where we are for 50,001 certification in one of our bog sites. So we were set up in 1934 by the Irish Turf Development Board. The main technology at the time was sod peat, which was German technology, very little off-the-shelf technology in those days. Where then Enda itself was established in 1946 by the Irish government, whose original purpose was to develop Ireland's peat resource, and still remains the main driver for what we do with our peatlands. From then it moved on to mill peat, which was mostly Russian technology, and then we would have impacted then a large cohort of our operations, or all of them are practically in the Midlands, so it had a big impact on the Midland communities. This is what we were at back in those days, supplying turf. That stocked the turf in Phoenix Park for probably heating a lot of your ancestors here in Dublin during the war. So we moved on a bit from that. These were sort of advertisements. We were looking for workers wanted. A lot of people would argue that the pay rates haven't changed a lot. The currency has, but the pay rates are pretty much the same. These are some of the hostels we had in our site for housing workers during the summer season. Some of the existing housing estates built at the time that still remain down in the Midland communities. We also have four of the businesses then. The fuels business people will be familiar with, which will be our Fire Magic project, the eco range of fuel products, peat briquettes, everyone's familiar with. We import and distribute coal, and we have an oil distribution business, or we've recently sold that on. Horticultural business again, the upper layers of the peat generally are the horticultural grade peat, so we supply a lot of the domestic market, and we have a significant export market to Europe for the commercial growers. Power gen business, we have one power station in Eden. We have Mount Lucas wind farm nearing completion in County Offaly on our Coolway Bogs. We have another one nearing completion in Tipperary, and we have an existing wind farm in Onini that we're extending the next year. Resource recovery business, we AES have some operations I think in Dublin, but mostly down in the Midlands. Waste operators, we have a landfill in Kildare, and we recycle and divert waste from landfill. And then finally the last part of our business is Anua, which is our wastewater treatment business, the Pure for other people might be familiar with. Water reuse and rainwater harvesting, air and odour control, and we have operations then in Ireland, Europe and North America. The land and property business in biodiversity internally looks after what we do with our peatlands when we're finished. We have lots of tourism, parklands and bog conservation goals and intentions. We have a water storage project we're looking at in Garryhinch near Portarlington. We possibly will store water from the Shannon. And then we have a significant wind energy portfolio that we're hoping to roll out over the next couple of years. The sustainability of our business then, obviously, the wind farms, the biomass and peat dilution. We have targets to substitute 30% of our peat in Eden Dairy Power by 2020, and we're well on that road. We are not opening any new bogs. We have biodiversity action plans, and we have the Lochbura Parklands, which also covers what we do. That slide is very much the same thing. The feedstock business. So we supply peat to Eden Dairy Power, which is our own power station, and two of the power stations owned and run by DSB. The total electricity supply for Enda peat generated power stations and DSB is about 6 or 7%. We source biomass for co-fueling. A lot of it's imported. Some of it is from local waste from forestry operations, sawmills, and in some cases some successful willow growing from local farming activities. And then we supply the peat for the briquettes. So there are the facts about what we do. I'll fly through this again. Our energy use. Okay. So we spend about $1 million a year on electricity on over 180 electricity sites. A lot of that would be pumping, workshops and offices. Our fuel bill is rising. 8 million last year on fuel, over 30 fuel tank sites. We have about 30 different operations in the Midlands that require fuel, powering over 1,900 plant and vehicles. Just to show that our energy costs are about 8 and 1 for electricity and fuel. And the difference in the difference in actual usage per location depends on the cost difference per kilowatt hour. The significant energy uses in our business then are our production and our road fuel. So our road transportation and support would count, which would be our derv diesel, would account for 40% of our operations. 86 of them would be for production. So we produce roughly about 4 million tonnes of peat a year, and we have a large tractor fleet in operations that produce that. So that's the significant part of our diesel usage. We have a large fleet. We have over 1,000 tractors in operation, some of them leased, some of them purchased, and a large number of dozers, excavators, locomotives for hauling our peat, trucks, various plant and equipment that operate across the business. A breakdown of electricity use then, that's 60 or 70% of it then comes from our workshops and offices that supply and maintain our fleet, and the remaining then would be bog pumps. We pump a lot of water. As we work our way down to our peatlands, we eventually go under the local water tables we have to pump. So it depends on what part of the country, and if you're in Mount Dillon Group, which we'll talk about, we would be pumping more than the other areas. So we joined the large industry energy network in 2009, signed up to the energy agreements program run by SEAI in 2009. We attended a course, Joe and I, and a few other colleagues, on IS 393 at the time. We got a gap analysis carried out to see where we were regarding our metering and our data analysis. We then had assistance on the energy agreements program with a James Conroy from Capstone Energy, who helped us to understand what our energy use was and where our factors were. We then picked the Mount Dillon group of bogs to implement this, which is mostly on the Roscommon area. We began the process of installing 16,001, and then we're quickly told halfway through it that actually you better change that to 50,001 because we would have been old technology. So the little bit we learned about 60,001 and 50,001 seemed to have been a big improvement on simplicity. So we applied in 2012, we got certified in 2012. We had audited in 13 and 14 this year, and we're still compliant. Significant audit coming then on the 3-year anniversary next year. And then we got certified. So Mount Dillon Group of Bogs is based in Lanesborough, straddling the Shannon, and supply the power station. We produce that many tonnes of mill peat at a specific moisture content, and we sell a little bit more than that every year to the Loughery power station at ESB. So, as people are aware, or may become aware as we later on to the data management system, the important parts broken down in the system are the management responsibility, which we talked about earlier on. We had to develop our energy policy. We had to analyse, identify our variables, so we had very little information and data on our energy use. The bills came in, were stamped and paid, and that was about it. We had little information on our baselines. We had no indication of typical EPIs that we should use to measure our business. We have obviously worked complying with our legal requirements regarding procurement in the public sector. We carried out an energy review and established an energy baseline and the EPIs I'll talk about. We identified energy objectives, targets and plans, some successful, some not so. We needed to hit on the road about competence, awareness and training. So training and awareness now has moved on to competence. And then communicate what we were doing and document everything. We were reasonably good at the cranks, plenty of cranks in the business that were fixated on fuel use, but there was very poor documentation about what we'd done. Then there's another part of the standard regarding design. We do a lot of design and in-house fabrication of our plant and equipment, and we didn't have any link between that and the energy use of the piece of equipment. We had very little information on assessing our procurement of our plant and vehicles on the energy assessment criteria, and then obviously the checking, monitoring and measurement of the data. So a top management commitment was important to establish first. We developed an energy policy, kept it reasonably brief, simple. We got it signed off by the head of our business unit, and the resource manager then is a manager targeted with managing the Mount Dillon group of bogs. Identified a team within that group, started the communications internally and externally within the business unit, developed 4 EPIs we consider were the main drivers or main methods of measuring what we did. We established our team, which is made up by the managers, mechanical input, environmental input, records keepers important, and then the innovation and looking at electrical operations, which are 2 main drivers. The second big part of 5001 is the planning, so you've got to analyse your energy use and your consumption, identify areas of significant energy use, and then look for opportunities to improve those, which involve looking at past and present energy use. As I said before, we had poor enough records on our previous energy consumption. We mapped all of our energy uses, which was a big bit of work. We had numerous sites had not been read for a number of years, so when we started getting our meter readings submitted, we were hit with, in some cases, large bills for that undo the good work we'd done the previous month, but we convinced management would be better off to be paying exactly what we're using. Somebody could get on this road. We need to establish who pays the energy bills in the business. That wasn't very clear. We set up procedures for submission of monthly meter readings. So a lot of our sites are very remote. In some cases, you would have to travel in a van and hop on a tractor, and you could be travelling for half an hour at the bob before you get to a substation or a location. So they were never going to be read externally. We reviewed our Meridial fuel management system. We removed the key fob nailed to the door. So we had a fuel management system with a key fob. In a lot of cases, just nailed to the door that everyone used. We had to remove that. Allocate key fobs to all of our vehicles, plant and equipment, which required odometer readings or hours worked. So what was the main driver? Applied our EPIs, and then looked at and documented all the facts influencing our energy use. So those, despite our business being probably nothing more than an intensive farming business, there were a lot of factors other than the obvious one being the weather that influenced what we did. So we have a large number of substations. We have 3 substations in Mount Dillon. A lot of our sites were the old sod sites. We had our own power supply out the bogs. We have substation sites. We had to get these all mapped and located, establish what was on them. Screw pumps, submersible pumps, and then on top of all those, then we had a plus 22 of the direct meter sites. So as the local network improved with ESB, then a lot of our connections from maybe 20 years ago on were direct metered sites. But again, would have had no quarterly hourly metering or very little data. So in our production is our biggest significant energy user. Our influencing factors are obviously our targets for the year. The weather is a huge and continues to be a huge factor. We haven't, in the last 3 years, we haven't had 3 years the same. We've had a record year, a good year this year, a bumper year the previous year, and the worst record in history the previous year. So very hard to get analysis on our data and our energy when you have such up and down years. We need to look at what tractors to procure or lease, what the tractor was used for, how it was maintained and operated. This is fairly standard for any fleet. What attachment we procured, leased, designed or fabricated that assisted in the production process, how it was used, maintained and operated. For road transport, our EPI is litres per tonne kilometre, so our diesel input was over 200,000 litres usage. We'd look at our customer requirements that would indicate our schedule. What trucks and trailers and plant and equipment we procured and leased, again the same as the tractor fleet. The distance we hauled, the density of the peat is a big factor. The denser the peat, the heavier it is, and which influences the weight of the peat, and the condition of the road and route, obviously enough. Regarding rail transport, we have a large infrastructure internal regarding transporting the peat by rail. So the influencing factors, again, they were very much the same. Our customer requirements, the condition of the rail line, are very same as the condition of the road. What locomotives we used, so we manufacture and fabricate our own locomotives. The amount of rakes, the amount of trailers that we haul, the maintenance and operation of the locomotive, and then again the same conditions regarding weight and density. The last one then, in Mount Dillon's case, was pumping. So we have a large 1.4 gigawatt hour pumping requirement to keep our bogs dry during the summer months for production and during the winter months for stockpile protection. Influencing factors, obviously enough rainfall, the type of pump. We still have a lot of old Archimedean screw pumps in our bogs that are generally removed once the bog gets too deep for the operation. The spec, size, the type of the pump. Very often pumps were ordered in bulk and left in the stores and just taken out and used in any operation. I think the general indication at the time was better to be looking at the power requirements than for it, which is fine when you're not paying the bill. The operation of the pump, the maintenance of the pump again, the lift and the catchment size. And our workshops and offices then, obviously enough heating, our machines, compressed air, it's a reasonable large requirement in our operations, and then lighting offices. And then the very same deciding factors that you typically would have an office or workshop, the number of people, the condition of the building itself, their activities and the existing operations and lighting and heating systems that were in place. So the third thing then was implementation and operation. So I talked about competence training and awareness. We have a significant training department in Bordamona that handles health and safety and environmental training. To communicate this within the feedstock or within the Mount Dillon Group business and also on the senior management team in feedstock to show what we were doing, and then the next plan is to implement those activities across the rest of the feedstock to other operations. Documentation, operation control. Design is a big factor. We have a centralised engineering services section to handle design. So if they add a piece of kit to a production unit, there was no consideration of what that might have added in or reducing energy efficiency. And then obviously procurement, how and why we procure the energy use that we have. Checking, monitoring, measurement and analysis, our legal requirements. Internal audits, so we had got some audits done through SEI. Conor Malloy conducted a few audits on our workshops. We also done a couple of internal audits ourselves. As I said, it's not too technical. Our biggest energy user was fuel. Very much often, a lot of the energy users are part-time farmers. They would have tractors that hold themselves, so it wasn't very technical activities to undertake. We had to identify and list our non-conformities and our corrective actions, preventative actions, and then do some analysis. So we conducted some regression analysis on our production. And if people are wondering, obviously people would be familiar with this regarding our R-squared analysis. The 0.88, they would indicate there was a reasonably good correlation between what we produced in tonnes and the fuel we used for that. So we were quite happy with that regression, that EPI was appropriate. We moved on further, we looked at our road transport. Road transport was transporting peat from A to B. Very little scope for peat for fuel wastage, so our regression was even better in those locations. Rail transport, not so good, typically going from a number of locations in the bog to various levels of road crossings, drivers, locomotives under various states of operation and maintenance. So our regression there was quite poor, 0.5. Pumping was even worse. One of our substations there, road pumping, our regression we carried out looking over a winter period had a regression of only 0.4, which showed that there was very little relationship between rainfall and pumping, which sounds a bit mad at this stage. So we broke it down to summer and winter. So a winter pumping regime, obviously during the summer when you have heavy rainfall events, it takes a bit longer to get to the pump. And the regression improved a little bit regarding splitting them up between winter and summer regime. So we hope to look at that further regarding metering. As I said, these are quarterly hourly meters, which have reasonable enough data, but we need to do a bit more intensive look at our individual pumps. A lot of the pumps are all based on the water level in the bog. In some cases you go out and they've been overridden by the production staff. If they see water held in the bog, they just decide, well, I just turn on the pump and leave it on for the weekend. And so just old practice that needs to be reviewed, and we need to sell it to them. So the management view then finally is the suitability of the system. So the system didn't need to be over-designed for what we were doing. As I said, we're a very simple enough business, nothing more than an intensive farming business. Fuel and electricity being our main impacts. Whether the system was adequate and its effectiveness. So the opportunity we identified for pumping, that's the typical bog operations. We're airline through it, where we pump our operations to the local river. We looked at diverting internal waters. A lot of external farmers' drainage water would have come to our sites. We looked where we could divert that water for the obvious reason. Take back control of our pumps. Again, they were installed by our electrical operations and 4 people, and they then might have been operated by the local works teams who wouldn't have been paying the bill, so we need to take back control of those. We need to look at gravity versus pump. Sometimes we could have deepened outfalls and continued our gravity, and it was easier maybe through poor planning just to throw a pump at the problem, and we're reviewing all those again to see can we take out pumps. We need to look at screw versus submersible. As I said, when the bog gets too deep to operate the screw pump, we need to switch over to submersible. Maybe we should put in submersibles now, and as the screw pumps just do the heavy lifting when you need to shift a lot of water. The operational controls, the spec procurement and the installation of the pump. We have procedures for these now. The operation maintenance, we did carry out some maintenance, but it was poorly documented and it didn't really dictate to a corrective action or identify problems in the system. Smarter controls, we got some money from SEI last year to install smart pump panels. We're looking at winter and summer pumping regimes. They obviously correct tariff, which seems fairly obvious, and then winter peak. These won't save energy, but they'll contribute to our cost savings, which will help to drive on the message. Regarding production, we've done a bit of retuning on our tractors. Our tractor fleet would have been bought in, and through various either falling out of spec or factory settings, or by production staff adjusting a few knobs here and there just to increase horsepower. We need to retune our tractors, so we got a 5% saving there for very little work regarding bringing our tractors back to what I call factory settings. Big problem with idle travelling and idling. The procurement of our fleet, we lease a lot of our fleet now because the fleet size wouldn't allow procurement. We have an eco-driving module and being prepared at the moment to cover our drivers and how they should operate, and dyno testing of our tractors before they leave the workshops. Looked at tyres, fuel additives, the right tractor for the right job, so we have varying tractors out there for the various operations. Lean processing again will also help in identifying wastage, and then the quality management system which we have. The biggest bit of work that came recently that was dictated by this would be our new road fleet. So we took in 4 trucks on test to one of our works, ran a test program over a month where the truck suppliers, Scania, MAN, Volvo, and MAN, Volvo, Scania, and what's the last one? Yes, exactly, sorry. They supplied us with a truck. We operated them for a month. We had an instructor provided with all of those, so the drivers were bought out without instruction and under instruction for a period of time. We learned more about our drivers than we probably did about our trucks. It did go to some way to influence the factor in our truck lease program, but we learned more, as I said, about our drivers and the good and bad practice and how we might implement an eco-drive and training module with those. So we had a good handover process. Previously, that the truck would have been dropped down and the keys thrown at the driver. So we then decided we'd have a handover process that would include eco-driving, telematics, covering the trailer. We didn't cover our trailers when we'd be coming back with an empty load and we discovered there was a drag on the trailer, so we got those covered. And a bit more analysis on the aerodynamics kit of the trucks when we procured them. Rail transport, again, we've been replacing our engines at a phase, very little thought into the energy efficiency of the engine. Sometimes the emissions directive drives what engine we have to select. Eco-driving, the rail line condition, and then looking at increased wagons. Other opportunities, we looked at our direct fuel deliveries. We have a large number of fleet hauling fuel on the bog, so we're looking at getting permission, which we did do from the EPA, to go for direct deliveries to bog, which will cut out a large amount of locomotives and fuel wagons. Compressed air lighting and heating. And then we took part in an energy awareness programme through SCI last year, which will help to drive what we're doing. And we have an also initiative at the moment with a lot of the company cars and company vehicles where we can track how we're going on our safe driving and our fuel efficiency. That's just an idea of some of the more simpler initiatives in the localised work areas, where we have a very simple hour meter that indicates what were our winter peak and our different charges during the day so people can see. We've produced these energy efficient, 5 minutes, lovely. Some of our projects identified during the year in Mount Dillon. So we've looked at our road fleet, our targets for we have to predict what fuel we use. A lot of it's to do with the weather conditions we're enduring, so we have to indicate where our fuel has been used and whether we're keeping on track of that target. Now, that's a preliminary requirement of 50,001. Then we looked at projects for 2013, which are pumping workshops, production, rail and road, and we've outlined those. So this is the type of information we provide on notice boards. This is just an indication of the download. We downloaded our John Deere tractor fleet, or John Deere did for us, and this is an indication between 5% and up to 25% of the time there was idling. So a certain amount of requirements would cover idling, like when they are queuing up with their trailers to get filled, or when they're at T-centres for various operations or for warming down turbos. So we've indicated, there's definitely 10% might be the ideal requirement for idling regarding turbos, but there's a prize above the 10% that we hope will tackle with an energy awareness programme. That's the poster that we produced from that. We studied the 33% large tractors and that it could be costing us up to $66,000 a year in idling. And that's not including the idling that the spec would indicate for maintenance of the engine. So let's stop the wastage, let's stop idling. They're very simple messages that people understand. Kilowatt hours we started out with in fuel, or litres equivalent, which probably was lost in a lot of people, so we went back to litres. Project completed, we talked about the aerodynamics. We rerouted some of our trucks to get a bit 5% saving. We retuned our tractor fleet. We talked about the idling. We have a large compressed air requirement in our workshops. We didn't have any maintenance. Sometimes we went into a workshop, it sounded like we were going into a snake pit at tea time there with the hissing. So we got those in order. We had our new transport fleet lease, which is a more efficient truck. When it's on the route that we hope will start shortly, we'll be able to analyse whether we picked the correct truck and whether the driver influence has any impact in that. Our pump catchment surveys. We got approval from the EPA for direct deliveries, which is an environmental requirement, so we hope that that project will take some of our fuel used for transporting fuel on the bog out of the loop. Fuel management system, as I said, we have a Meridian system that is now up to speed. In a lot of other areas, it was the fob which was nailed to the door. Management review over MICs, so they can go up and down as kit and pumps are added to our system. Prior to that, there was no management of our maximum import capacity, so we analysed that and lower it or reduce it as required. And then the maintenance and control of our pumps, smart metering and controls. So we're going to look at our workshop. We have old workshops, no insulation. A lot of them have roof lights that are caked and covered in dirt over the years, so there's a natural light background level we could achieve there. We're looking at IR heaters. We have very inefficient heaters that heat the space and not the person, so IR heatings might be the way to go for our workshops. Obviously submersible versus screw pumps, gravity versus pumped, the awareness campaign I talked about earlier on that we'll be rolling out, and the eco-driver training module for road and production, and then the spec and trial of our direct fuel delivery system. So what was our review at the end of the year? What did we achieve? So we got a 5% target for road usage, so we got a 4% reduction this year on a road transported fuel for very little work really, a lot of it down to the selection of the road fleet and a bit of work on the trailer coverings and picking the correct kit. We had no change in our rail use, so after 2 years we've learned a lot, we have a system in place, and we're hoping the next year that we'll start to see the dividends. Production, a slight influence or improvement on production from a previous 1.89 litres per tonne down to 1.16. A lot of that's down to good production year weather-wise, so we need to analyse that further to see what can be attributed to the energy management system. And then pumping, we had a drop of 4.5% in 2012 on our kilowatt hours used. This again is driven by a lot of rainfall, but again appropriate pump production or selection, operation and maintenance can help in those. So the do's: get your energy team together, establish energy use from suppliers, consider installing fuel and energy meters if data is poor. So these are things that, again, a lot of industry that mightn't be as remote to ourselves may already have this. Start submitting meter readings. Use your suppliers' online resources. Some of your suppliers have fairly good online data that's available for your use. Look at existing initiatives. A lot of people are already doing initiatives in your organisation, but they're not recorded. Brainstorm ideas. Communicate with personnel through emails, notice boards, canteen. This is fairly standard. Consider cost centres. Again, we had one department paying for all of our bills, regardless of what department they're from. The do is, again, measure and record. Look at existing energy recording and optimise. So look at the system you have. Maybe it's good enough. Optimise existing controls first. So look what you have first. Very often they can be existing controls or functions and software that allow you to do a bit more energy influence on what you're doing as opposed to buying new pieces of plant and equipment. Look at life cycle analysis, total cost of ownership. Measure what you're doing now. Consider what help SEI can provide, and you can do that today. Look at energy awareness campaigns. Look at uncoupling energy from increased output. So where your output increases, try to uncouple the inevitable where your energy input will increase, and try and ensure that your energy drops, obviously, where you reduce your production output. Get procurement on board and include in their policy. Some more do's, I think. Consider the output. We started off in kilowatt hours. We changed that to litres so that people could understand what we're talking about. Make it part of someone's energy performance management. Consider, in the case of multiple sites, getting one site certified like we're doing and manage using a league table. So we have production units in the bogs that we hope to start a league table of who's using the most fuel per tonne produced. Pick your EPIs carefully. Make energy use part of induction. So as people come in, we have seasonal staff that come in during the summer, and they're part of their induction programme, and equate a lot of these activities to energy use in the home. So if you're using a light of work or heating or a tractor, equate it to what you're doing at home. Don't rush your opportunities, measure and implement a measure. Don't rely on supplier data for your energy management system, as we found out. Don't worry about identifying the big opportunities in year 1 and 2. It's about understanding and managing your energy in the years 1 and 2. Don't look at winning any awards. I won't get any awards for timekeeping at this stage. Don't worry about your euros and your carbon tonnes first. Your kilowatt hours your main focus. Don't ever specify your energy policy. That's it. Sorry for rushing the last year. Thank you.